Good morning, Algebra 2 students. Today we're just going to review some of the operations with radicals and then expand on a little bit with addition and subtraction. But on Friday we talked about the product property, which is when you have the nth root of AB, you can break that up into the nth root of A times the nth root of B. So what this allows us to do is to simplify expressions. So if you look at this example of the root of 48, obviously you can break this up into root 8 times root 6. Neither one of those is a perfect square, so it doesn't really help you to simplify that. So we want to look at factors of 48, which are perfect squares. 4 is one of those, but also 16, and that is a greatest perfect square factor of that. So I can break this up into root 16 times root 3. The root of 16 is simply 4, and so root of 48 could be written as 4 root 3. Square root of 45, 9 goes in there. I could break that up as to root 9 times root 5, and then my final simplified answer would be 3 root 5. Quotient property, if you have the nth root of A over B, you can break it up as the nth root of A divided by the nth root of B. So examples here, this I could write as the root of 12 over the root of 25. The root of 12 I could break up into, using product property, root 4 root 3. And the root of 25 is a perfect square, which is simply 5. So on the top, I would have 2 root 3 divided by 5. This next one I could break up into root 9 over root 5. Root 9 is 3. Root 5 cannot be simplified. So this brings up another thing we need to concern ourselves when simplifying radicals, is that we should never have a radical sign in the denominator. So we need to do what's called rationalizing this. That means I'm going to multiply the top and the bottom of this expression by the root of 5. So on the top I'd have 3 root 5. On the bottom I have root 5 times root 5, which is root of 25, which comes out to be 5. So that is a way to get rid of that radical in the denominator, called rationalizing the denominator. Now, when adding radical expressions, again, very simply, what we've done all year long when we're adding is we combine like terms. In this case, we're going to combine like radicals. That means they have to have the same index. So like the square root of 5 and 3 square root 5 have the same radicand. Those would be similar terms. And I could combine those to be 4 root 5. If they're both cube roots, the only thing that changes would be 4 times the cube root of 5. So the index and then the radicand has to be the same for them to be like radicals. So examples here, adding these radicals, the first thing I'd do is simplify them. 3 root 2 I cannot simplify. Root 50 could be broken up into root 25 times root 2, which would be then 5 root 2. And root 8 could be broken up into root 4 times root 2. So then I have 4 times 2, which is 8 root 2. Now you can see I've got all like terms. So 3 root 2 plus 5 root 2 would be 8 root 2. Minus the 8 root 2 would be 0 root 2, which is simply 0. This next one, the root of 300, I could break into root 100 times root 3, which is 10 root 3. The root of 27, I could break into 9 and 3, so that'd be 3 root 3. And 75, I could break into 25 and 3, which would be 5 root 3. Now combining these, and I could do this in any order. If I combine these two, that would be 7 root 3, because they're like terms. And then I'm subtracting 5 root 3, which would give me 2 root 3. So when you're adding expressions, you're going to combine like radicals. When subtracting, just add the opposite, as we've done all year long. Now, when we're multiplying radical expressions, we're going to use the product property and then FOIL and distribute like we've always done. So for this first example, I could do this a couple different ways. The first thing I could do is try to simplify any radical. So 2 root 3 cannot be simplified, root 15 cannot, but the root of 60 could be broken up into root 4 and root 15, which is 2 root 15. So now, on the inside, I do have like terms. I could combine those to be 3 root 15. And now when I multiply these, I would get 6 root 45, because root 3 times root 15 is root 45. Then I could break this up into 9 and 5, and this 9 is 3. So I end up with 18 root 5. Lots of different ways you could do this. You could distribute right away. If you did that, you'd have 2 root 45 plus 2 root 180. And then you could break these up. 45 could be 9 and 5. The root of 180 could be broken up into 36 and 5. So now this is 6 root 5 plus 2 times 6 is 12 root 5, and you can see I get the same answer as 18 root 5. Here I've got two binomials, so like we normally do, we're going to FOIL. So first terms would be 8. Outside terms would be 2 root 7. Inside terms would be 12 root 7. And then our last terms is 3 times root 7 times root 7. Root 7 times root 7 is simply 7. So that's like 3 times 7, which is 21. Now I combine like terms. So I'd have 29 plus 14 root 7, because those are like terms. Here I'm doing some division. Again, I could simplify these radicals as much as I can. I think 48 could be 16 and 3. 75 would be 25 and 3. So now I've got 20 root 3 plus 5 root 3 on the top, which is 25 root 3. I'm dividing that by 5 root 3. Those root 3's are going to cancel, and 25 divided by 5 is 5. That's probably the best way of doing that. You could simply rationalize that right away. Last example. Now we've got a binomial on the bottom. So I'm going to multiply by the conjugate of the bottom. The conjugate of the bottom, which is 1 minus 2 root 3. What I do to the bottom, I must do the top. So I kind of turn this into two multiplication problems. Why do I do this? Because on the bottom, I'm going to get 1, and then you're going to get a negative 2 root 3, a positive 2 root 3. If you use conjugates, those outside and inside terms will always cancel. And then my last terms would be a negative 4 root 9, which is 3. So on the bottom, I have 1 minus 12, which is a negative 11. So I've gotten rid of the square root in the bottom. Then I'd FOIL the top, so I've got 5. minus 10 root 3. I've got a negative 3 root 3. And then I've got a positive 6 times root 3 times root 3, which is 3. Positive 6 times 3 is 18. And then I'd combine like terms, so I'd have 23 minus 13 root 3. So this video's got a lot of information in. You can watch it slowly, rewind, rewatch it, and then use this to complete the assignment. So on the practice, the 7.5 practice, I would like you to do the right-hand column 3 through 33, every third problem, so 3, 6, 9, 12, 15, and so on all the way to 33.